ATLASrift lets you visit the ATLAS experiment at CERN, the world's largest particle physics laboratory. Here are some standard options. Users with Oculus Rift ready machines can go full epic with graphic settings. ATLASrift works with or without VR headset and supports keyboard, mouse, and game controller. Ask your high-energy physicist friends to give you a virtual walkthrough and discuss some collision events. Welcome to the ATLAS Experiment Cavern. Feel free to fly around. Forward direction is the direction you are looking at. Use keys to change how different sub-detectors are visualized. Use the left mouse button or A key on your controller to bring up the main menu. A selected option is changed by moving your head left or right. To see some of the cavern support structures, press the minus key. If you have ever visited the ATLAS Cavern, this is the only place you are allowed to be in. To be here, one needs a good reason, has to pass safety courses, and have a personal dosimeter. To work here, physicists often use a cherry picker. Let's look at some collision events. Press the F key to load the next event. Energy that the created particles deposited in the calorimeter are represented by yellow boxes we call clusters. Paths of the charged particles are represented by light blue curves we call tracks. When a lot of them concentrate in one direction, we call it a jet and represent it with a red cone. One can use the Event menu option to load events or change how an event is visualized. Finally, take a guided tour. It will fly you around a bit, but feel free to look all around.
100 meters underground, in a 27-kilometer circular tunnel across the Franco-Swiss border, lies the world's most powerful accelerator, CERN's Large Hadron Collider, or the LHC. Inside the tunnel, protons are accelerated to extremely high energies and made to collide in the heart of the LHC's 4 major experiments. The collisions create conditions similar to those that occurred shortly after the birth of the universe. We examine the debris from these collisions to learn about the composition of matter and the fundamental forces of nature. Of the 4 major detectors, ATLAS and CMS are the largest and most complex. We are now standing 80 meters directly above the ATLAS detector. This is the shaft through which parts of the detector were lowered during the construction phase, which is still used during upgrade and maintenance periods. The ATLAS detector itself took around 18 years to build. Its components were constructed at universities and laboratories around the world and brought to CERN, assembled, tested, and lowered into the cavern one by one. The ATLAS collaboration comprises 3,000 scientists from around 180 institutions around the world, representing 38 countries from all the world's populated continents. It is one of the largest collaborative efforts ever attempted in science. Almost 1,200 doctoral students are involved in detector development, data collection, and analysis. ATLAS measures 46 meters long and 25 meters in diameter and is the largest volume detector ever constructed for a particle collider. It is a many-layered instrument designed to detect some of the tiniest yet most energetic particles ever created on Earth. It consists of several different detecting subsystems wrapped concentrically in layers around the collision point to record the trajectory, momentum, and energy of particles, allowing them to be individually identified and measured. A huge magnet system bends the paths of the charged particles so that their momenta can be measured as precisely as possible. Beams of particles travel